National Electrical Code Section 517.13 addresses patient care areas, stating that in these areas, all branch circuits and feeders supplying permanently installed equipment must be protected by a ground fault circuit interrupter, commonly referred to as a GFCI. National Electrical Code Section 517.13b focuses on the equipment grounding conductor, stating that the equipment grounding conductor for patient care areas should be installed according to Section 250.118 and must be insulated or isolated similarly to the circuit conductors. The question of whether HCFAC cable is suitable for critical and emergency branch circuits in patient areas compared to metallic conduit and an insulated ground wire requires careful consideration of the National Electrical Code. HCFAC cable is often presented as a viable alternative to traditional conduit systems. While National Electrical Code Sections 517.13 and B do not explicitly mandate the use of conduit or insulated ground wires for critical and emergency branch circuits within patient areas, it is crucial to understand the implications and related code requirements. The National Electrical Code Handbook serves as a valuable resource, offering insights into acceptable alternatives. The 2005 National Electrical Code Handbook, for instance, acknowledges HCFAC cable as a suitable alternative to conduit and an insulated ground wire for these specific circuits. However, it's essential to recognize that National Electrical Code Sections 517.13 and B are not the only relevant code sections governing patient care area circuits. Other sections also apply, including National Electrical Code Section 210.8A7, which mandates GFCI protection for all 125 volts, single-phase, 15 amps and 20 amps receptacles installed in patient care areas of hospitals and other healthcare facilities. Another important section is National Electrical Code Section 517.20, which requires all electrical equipment in patient care areas to be certified to a recognized medical equipment standard. Additionally, National Electrical Code Section 517.21 stipulates that all electrical equipment in patient care areas must be maintained according to the manufacturer's instructions. When evaluating the suitability of HCFAC cable, consider firstly the specific requirements outlined in National Electrical Code Sections 517.13 and B regarding ground fault protection and grounding conductors. Secondly, consult the National Electrical Code Handbook for guidance on acceptable alternatives like HCFAC cable. Thirdly, ensure compliance with other relevant National Electrical Code sections such as 210.8A7, 517.20, and 517.21, which address GFCI protection, equipment certification, and maintenance. Fourthly, always consult with a qualified electrician or code expert to ensure full compliance with all applicable code requirements in your specific jurisdiction. The determination of whether HCFAC cable is an acceptable alternative often hinges on factors such as local amendments, interpretations by electrical inspectors, and project specifications. While the National Electrical Code provides a baseline for electrical safety, local regulations and interpretations can vary. Using HCFAC cable in healthcare facilities necessitates a comprehensive understanding of not only the National Electrical Code but also any supplemental requirements imposed by local authorities or healthcare facility policies. Grounding is a critical aspect of electrical safety, particularly in patient care areas. The integrity of the grounding system is paramount to minimizing the risk of electrical shock. The National Electrical Code emphasizes the importance of a lower impedance ground path to facilitate the safe and effective operation of overcurrent protection devices. In patient care areas, maintaining a robust and reliable grounding system is non-negotiable. The use of insulated grounding conductors, as specified in National Electrical Code Section 517.13b, is intended to further enhance safety by minimizing the potential for stray currents and voltage gradients. Ground fault circuit interrupters play a pivotal role in protecting patients and healthcare personnel from electrical shock hazards. These devices are designed to detect even small imbalances in current flow, quickly interrupting the circuit to prevent injury. National Electrical Code Section 210.8 mandates GFCI protection for receptacles in patient care areas, reflecting the heightened risk of electrical shock in these environments. Proper installation and regular testing of ground fault circuit interrupters are essential to ensure their effectiveness. Healthcare facilities present unique challenges in terms of electrical safety due to the presence of sensitive medical equipment and vulnerable patients. The National Electrical Code recognizes these challenges and includes specific provisions tailored to healthcare occupancies. These provisions address a wide range of issues, including power reliability, grounding, and the use of specialized wiring methods. Compliance with these requirements is essential to ensuring a safe and reliable electrical system within healthcare facilities. When considering the use of HCFAC cable in healthcare facilities, it's crucial to evaluate its suitability in relation to the specific requirements outlined in the National Electrical Code and other applicable standards. Factors such as the type of patient care area, the sensitivity of medical equipment, and the potential for electrical hazards must all be taken into account. A thorough risk assessment can help identify potential hazards and inform decisions about wiring methods and grounding practices. In addition to the National Electrical Code, other standards and guidelines may also be relevant to electrical safety in healthcare facilities. These may include standards from organizations such as the National Fire Protection Association, the Joint Commission, and the International Electrotechnical Commission. Adhering to these standards can help ensure a comprehensive approach to electrical safety. The selection of wiring methods for patient care areas should be based on a careful evaluation of factors such as cost, installation requirements, and performance characteristics. HCFAC cable offers certain advantages in terms of ease of installation and flexibility. However, it's essential to ensure that it meets all applicable code requirements and performance standards. Metallic conduit provides a high degree of mechanical protection and is often preferred in areas where physical damage is a concern. Ultimately, the choice of wiring method should be based on a comprehensive assessment of the specific needs of the healthcare facility. Ongoing maintenance and testing are essential to ensuring the continued safety and reliability of electrical systems in patient care areas. Regular inspections should be conducted to identify any signs of damage or deterioration. Grounding systems should be tested periodically to verify their integrity. Ground fault circuit interrupters should be tested monthly to ensure they are functioning properly. Any deficiencies should be promptly corrected to prevent potential hazards. Electrical safety in healthcare facilities is a shared responsibility involving electricians, facility managers, healthcare professionals, and regulatory agencies. Open communication and collaboration are essential to ensuring a safe and reliable electrical environment. Ongoing training and education can help raise awareness of electrical hazards and promote safe work practices. By working together, stakeholders can minimize the risk of electrical incidents and protect patients and healthcare personnel from harm. Understanding the nuances of the National Electrical Code, particularly sections related to healthcare facilities, is crucial for ensuring electrical safety. HCFAC cable can be a viable option for certain applications, but its suitability must be carefully evaluated in relation to all applicable code requirements and standards. Consulting with qualified professionals and adhering to best practices are essential to creating a safe and reliable electrical environment in patient care areas. The information provided should be used as a guide and not as a substitute for consulting the National Electrical Code and qualified professionals. It is the responsibility of individuals using this information to ensure compliance with all applicable codes and standards. Consider the electrical service requirements for the building. Calculate the demand load. Ensure proper overcurrent protection. Comply with all applicable local codes. Review the plans with the local inspector. Use a qualified electrician. Ensure all work is permitted and inspected. Keep accurate records of all electrical work. Train staff on electrical safety procedures. Post emergency contact information near electrical panels. Maintain a safe distance from electrical equipment. Use appropriate personal protective equipment. De-energize circuits before working on them. Lockout and tagout procedures should be followed. Test circuits to verify they are de-energized. Use insulated tools when working on electrical equipment. Avoid working on electrical equipment in wet conditions. Report any electrical hazards immediately. Investigate all electrical incidents thoroughly. Implement corrective actions to prevent future incidents. Regularly review and update electrical safety procedures. Foster a culture of electrical safety throughout the organization. Electrical systems play a vital role in modern healthcare facilities, powering life-saving equipment and supporting essential patient care services. A reliable and safe electrical system is paramount to ensuring the well-being of patients and staff. Strict adherence to electrical codes and standards is essential to minimizing the risk of electrical hazards. Proper design, installation, and maintenance of electrical systems are critical to maintaining a safe and reliable healthcare environment. Electrical safety is not just a matter of compliance, it is a moral imperative to protect the lives of patients and healthcare personnel. In addition to National Electrical Code Section 517, consider other relevant sections such as 517.10, which covers wiring methods for essential electrical systems, and 517.11, which addresses the transfer of power from normal to emergency sources. Also, consider Article 700, Emergency Systems, and Article 701, Legally Required Standby Systems, as these provide additional requirements for emergency power systems in healthcare facilities. Ensure that the emergency power system is adequately sized to support all essential loads. Conduct regular load testing of the emergency power system to verify its capacity. Maintain a written record of all load testing results. Provide backup power for critical medical equipment. Implement procedures for transferring power to backup sources during power outages. Train staff on how to operate and maintain the emergency power system. Post clear instructions for operating the emergency power system. Conduct regular drills to simulate power outages. Evaluate the performance of the emergency power system during drills. Make necessary adjustments to improve the reliability of the emergency power system. The selection of wiring methods and equipment for patient care areas should be based on a comprehensive risk assessment. The risk assessment should consider factors such as the types of medical procedures performed, the sensitivity of the patients, and the potential for environmental hazards. The wiring methods and equipment should be selected to minimize the risk of electrical shock, fire, and other hazards. Regular inspections should be conducted to identify any potential hazards. The inspections should be conducted by qualified personnel who are familiar with electrical codes and standards. Any identified hazards should be promptly corrected. The electrical system should be tested regularly to verify its performance. The testing should be conducted by qualified personnel who are familiar with electrical codes and standards. The results of the testing should be documented and used to identify any necessary repairs or upgrades. The National Electrical Code is updated every 3 years, so it is important to stay current with the latest requirements. Changes to the National Electrical Code can affect the design, installation, and maintenance of electrical systems in patient care areas. Consulting with qualified professionals is essential to ensuring compliance with the latest code requirements. The use of isolated power systems is often required in critical care areas to minimize the risk of electrical shock. Isolated power systems provide a high degree of isolation between the electrical system and the patient. This isolation reduces the potential for leakage current to flow through the patient's body. Isolated power systems should be installed and maintained in accordance with National Electrical Code requirements. The performance of isolated power systems should be tested regularly to verify their effectiveness. Proper grounding is essential for electrical safety in patient care areas. The grounding system should be designed to provide a lower impedance path for fault current to flow back to the source. This low impedance path helps to ensure that overcurrent protection devices operate quickly to clear faults. The grounding system should be installed and maintained in accordance with National Electrical Code requirements. The integrity of the grounding system should be tested regularly to verify its effectiveness. Surge protection devices should be installed to protect sensitive electronic equipment from voltage surges. Voltage surges can damage electronic equipment and disrupt patient care services. Surge protection devices should be selected based on the voltage and current requirements of the protected equipment. The performance of surge protection devices should be tested regularly to verify their effectiveness. Regular maintenance is essential to ensure the continued safety and reliability of electrical systems in patient care areas. The maintenance program should include inspections, testing, cleaning, and repairs. The maintenance program should be documented and followed by qualified personnel. Any identified problems should be promptly corrected. Training is essential to ensure that personnel are aware of electrical hazards and safe work practices. The training program should include information on electrical codes, grounding, overcurrent protection, and the use of personal protective equipment. The training program should be documented and followed by all personnel who work on the electrical equipment. A comprehensive electrical safety program is essential to protecting patients and staff from electrical hazards in healthcare facilities. The electrical safety program should include policies, procedures, training, and maintenance. The electrical safety program should be documented and followed by all personnel. The electrical safety program should be regularly reviewed and updated to reflect changes in technology and code requirements. Healthcare facilities should work closely with qualified electrical professionals to develop and implement effective electrical safety programs. These professionals can provide expertise in electrical design, installation, maintenance, and training. By working together, healthcare facilities and electrical professionals can create a safer environment for patients and staff. The information provided here is intended as a general guide and should not be considered a substitute for professional advice. Always consult with qualified electrical professionals before making any decisions about electrical systems in healthcare facilities.